In this lecture, we're going to learn about abstract classes. So before we do that, let's take a look at what abstraction in general is. So data abstraction is basically a property where only essential details are displayed to the user. In other words, unwanted details are hidden from the user. So let's take a look at a real world example. Suppose you have a car and a driver. The driver only knows which of these pedals is the gas and which one is the brakes. Suppose he knows that if he hits this one, which is the gas, the car will speed up, and if he presses his foot down on this pedal, the car will slow down. However, he does not need to concern himself with the internals of how the car actually works, how the pistons in the brakes work or how the engine works. So the internal details that are hidden from the driver, that's basically an abstraction of sorts. And today we're going to be learning about abstract classes, which follows a very similar concept. So let's take a look at what abstract classes are. So an abstract class is a class that is declared with an abstract keyword. So generally, we declare a class like this. Say, suppose, let's call this shape. Normally, we would declare a class like this, but abstract classes are different in the sense that they are declared using a keyword called abstract. So this is basically an abstract class here. Okay. Next, an abstract method is one that is declared without an implementation. So an abstract method is one that does not basically have a body or an implementation. So let's declare an abstract method. So just like an abstract class, to declare an abstract method, you have to first use the abstract keyword. So let's call this method double area. So since it does not have an implementation, I'm going to end it here with a semicolon. So this is basically an abstract method. Okay. So next we have an abstract class may or may not have all abstract methods. Some of them can be concrete methods. So concrete methods are methods that actually have a body, or in other words, an implementation. So suppose, let's say this shape class has a variable called color and a concrete method called getColor, which returns whatever value is set in this variable color. So just like a regular class, an abstract class can have concrete methods like this as well. Okay. So next we have an abstract method must always be redefined in the subclass, thus making overriding compulsory. So basically, just like a class, you can inherit the contents of an abstract class as well. So let's create a subclass called rectangle, which is going to inherit the properties of this abstract class shape. So to inherit, we use the extends keyword. So class rectangle extends shape. So before I do that, let's create a main method. Let's call this one like class abstract test. Okay. So, like I was saying, an abstract method must always be redefined in the subclass. Redefined means that abstract method must be given some sort of an implementation here. So, you see, if I run this code without giving this abstract method an implementation in this class, I'll get an error. So let's run this and see, it's saying rectangle is not abstract and does not override abstract method area. So since we have not given any implementation of the abstract method area from the shape class, whose contents we inherited here in the rectangle class, we're getting an error. So to solve this, we can basically give an implementation to it. So to give an implementation, what we have to do is maintain the same method signature. So when we maintain a same method signature in a child class, so basically if I call this rectangle class a child class, The shape class is what? My parent class. So whenever you have two methods that have the exact same signature in the child class and parent class, we call this method overriding. That my child class rectangle is overriding my parent class's area method here. So let's give this an implementation. Let's say this rectangle class has variables x and y, and it's going to calculate the area by returning the multiplicand or the product of their values. So now we've given the previous abstract method an implementation here. So now let's run this. So now we don't have any error. So this is one way that we could get around this. The other is that unless the subclass itself is abstract, so this means we can avoid having to include an implementation for an abstract class in a subclass if that subclass itself is abstract. So normally, if I were to comment this out, if I did not give this double method an implementation here or did not override it here, I was getting what? An error, right? But if my subclass was abstract as well, I would not need to give this an implementation. So let's run this. So now you see I'm not getting any error. So basically an abstract method must always be redefined in the subclass, thus making overriding compulsory. The only time that you can get around this is when the subclass itself is abstract. Okay. So moving on, an instance of an abstract class cannot be created, instance/object. But, okay, so let's first take a look at this. So let's make this a regular class. So what this is saying is that we cannot create an instance of an abstract class, So to create an instance, we would need to write what? Shape, suppose any identifier object equals new shape. It's saying that we cannot create an object of any abstract class. So let's run this. And as you can see, it's saying that shape is abstract, it cannot be instantiated. In other words, simply put, you cannot create an object of an abstract class. You cannot instantiate an abstract class. However, we can have references of abstract class type though. So we can create a, suppose say, rectangle object. However, we can use the shape class, abstract class shape as its reference. So let's run this. And you see it works perfectly fine. So while an abstract class cannot be instantiated, it can be used as a reference. Okay. So now we can have an abstract class without any abstract method. So we don't always need to have an abstract method in our abstract class. So suppose, let me first of all comment this. So this was an abstract method here, right? What it's saying is that I don't need to always have an abstract method in my abstract class. So let's run this and you see, no problem. So now, if you take a look at, say, this class, abstract class, and this class, which has no abstract in it. So this is a regular class that we've been learning so far in our syllabus. And this is what? An abstract class. But both of them have the exact same properties, right? They both have a class variable called color, and they both have a method called getColor, which returns that value of that class variable color. So what is the difference between these two then? Well, first of all, we previously looked that we cannot create an object of an abstract class. So while you could create an object of this shape class, you could not create an object of this shape class since it is an abstract class. So that is basically what it's saying, that we can have an abstract class without any abstract method. This allows us to create classes that cannot be instantiated but can be inherited. And we already saw that abstract classes can be inherited. Okay, so that's that. Next up we have an abstract class can contain constructors. So just like a regular class, an abstract class can have constructor as well. So let's try one. Suppose this shape constructor is going to take a parameter color, which it is then going to set to its global variable. Okay. So now I want you guys to take a look at this and tell me if this is going to run or not. Well, if you've brushed up on your previous knowledge, you'd know that it would not. Why? Because from our class hierarchy lecture, we know that the parent class's constructor always runs first. So when the parent class's constructor runs, it's going to what? Require a string variable. But is anyone providing this shape class a string variable? The answer is no. So let's run this and see, we're getting an error here because it's not finding any arguments. It was supposed to get a string value as an argument. So to do that, what we can do is create a constructor for our child class as well. And in our child class, we can pass in a value to our parent class. And to do that, we need to use the super keyword. Suppose let's pass in the color string value red. And now we have our problem solved. Suppose let's instead make this a bit better and get this constructor to accept the value itself, which it is then going to pass. So this color value. So now what we have to do here is that we need to pass the string variable here. So there goes that we can have, basically an abstract class can have all the properties of a regular class, including having constructors. An abstract class can also have final methods. And what are final methods? Final methods are methods that cannot be overridden. So suppose let's first try overriding a normal method. Suppose we have this string getColor method, a getColor method that returns the value of this shape class. So if I were to call this getColor method here, what would my output be? My output would be red, since I'm passing red here. If I were to suppose write blue here, I'd get blue here instead. However, this is coming from my parent class's getColor method. What if I override this getColor method here? And now instead of passing in a variable, let me pass in a random string. This is a random color. Okay, so I've basically done what? Overridden my parent's method getColor. And when we execute this code, it's going to look for the getColor method in its class. Basically, we have created a rectangle object. Okay, for simplicity's sake, let's get rid of the reference here and paste it with rectangle. So this is basically a rectangle object and this is a rectangle reference. So when we call getColor method from this rectangle object, it's obviously going to execute the getColor method that it has. So let's run this and see. We're getting, this is a random color. This is basically how we can override regular methods. However, if you declare a method to be final, you cannot override it. So now that we've made getColor a final method, let's see what happens if we run the same code again. So now we get an error here that says cannot override getColor in shape. Why? Because overridden method is final. In other words, the method that I'm trying to override is a final method and final methods cannot be overridden. So that was basically abstract classes in a nutshell. Now, why would you need to use abstract classes? Well, there are situations in which you may want to define a superclass that places specific constraints on what behavior the child classes should incorporate. So suppose you're one of the developers in a project and you've created this abstract class shape, and there are other developers working in the same project who are going to create classes of different shapes. suppose someone has created this rectangle shape, a rectangle class, and we know he had one constraint, basically one enforced constraint, which was that he had to provide an implementation of this area method, because if he didn't, the code wouldn't run, since the class that he's inheriting is an abstract class and it has an abstract method. And we know abstract methods must always be given an implementation in their subclass, unless that subclass itself is abstract too. So let's try this again. Let's say another developer is going to create a class called circle, which extends shape. So now he's going to have to what? Override this abstract method area as well. So before we do that, let's suppose say declare a variable called r, which is for the radius, and just like before, we're going to need to have to pass in a specific string value to our parents constructor. So okay, now let's override this area method. And so for a circle, this area method is going to be different, right? So for circle, it's what? Pi r square. So let's get pi into r. So you could have imported this math library yourself here at the very top, and then use just math.py. It's up to you, but I've chosen not to do this since I'm only going to be needing to use pi just once. So basically, by creating this abstract class shape, I've enforced a constraint that any other coder or developer who's going to inherit my abstract class is going to have to give a specific implementation of its abstract area method. So that is one of the ways one of the use cases of abstract classes, besides the ones that I've previously mentioned. Okay. So in the next lecture, we're going to take a look at how interface works.